All right, in this video, I'm going to talk about how to graph tangent functions. You'll see that tangent functions are going to be fairly new to you guys. And you can see automatically that we have asymptotes going on, which makes sense because remember that in the coordinate plane for tangent, it's essentially the same thing as y over x. And if x is 0, then plot twist, that's not good. And when is x 0 on the unit circle? Well, 0, 1, 0, negative 1, or pi over 2, and 3 pi over 2. Then, of course, with coterminal angles, pi over 2 would be the same thing as negative 3 pi over 2, and then 3 pi over 2 will be the same thing as negative pi over 2. So with coterminal angles, you'll see that these would be my asymptotes. My period is going to be a little bit different. My period is actually going to be pi over b instead of 2 pi over b. Asymptotes are going to be odd multiples of pi over 2. You'll notice that from my distance of pi over 2 and 3 pi over 2 here to here, that it's just the distance of pi over 2. So pi over 2b. With a tangent function, we're going to have 3 pretty points. We are going to have the point at 0, 0. We're also going to have a point at pi over 4, 1, and negative pi over 4, 1. This is because if we have 0 degrees right here, this is 1, 0, or 0 over 1, which is how we get 0. When we have pi over 4, recall that pi over 4 is the same thing as root 2 over 2, comma root 2 over 2. So root 2 over 2 divided by root 2 over 2 is just 1. So that's how we get 1 right here. Likewise, we're going to get to negative 1 right here with negative pi over 4. Okay, so how do we graph these 3 points and then just copy and paste it? We are going to first identify my period by using pi over b. We're going to use my asymptotes, find my asymptotes, by using pi over 2b, and then using our phase shift if we have one, to accurately place the asymptotes. We are going to identify our midline, which is our d value right here. And that d value is going to be our new x-axis, essentially. We're going to make half sections between the midpoint and the asymptotes, meaning that we're going to have 3 sections. And this is what I mean. So technically 2. From my midpoint of my larger asymptotes, I'm going to create one fake asymptote right here. That tells me that I'm going to split it up so that I have this right here, this midpoint. And then from here to here, I'm going to have this midpoint. Now, how do I get these values right here? Well, that's our a value. In this case, since my basic parent function is tangent, it's just an a value of 1. So I'm just going to go up 1, down 1. Notice how I set a value in that amplitude. A tangent function does not have an amplitude. Okay, so let's look at 8. I have a period of pi over b, or just pi, since my b value is just 1. I know that I have a phase shift of minus pi over 2. And then my asymptote is pi over 2b. Well, I have a b value of 1, so it's just pi over 2. This is my asymptote, and then this negative pi over 2 represents my phase shift. Which tells me that pi over 2 minus pi over 2 is just 0, aka I have an asymptote at 0. And then since my period is pi, I'm just going to add on every pi so that my period from here to here and here to here and here to here is pi. I'm going to create my midline, which is at y is equal to 0. And then I am going to start finding my midpoints for one of my sections. I'm going to use 0 to pi, and I'm going to have pi over 2 as my section. Then I'm going to find midpoints from here to here, so that's going to be right here. Then I'm going to use my a value, which is just 1, to go up 1 to the right, and then down 1 to the left. And then since you have your 3 points, start graphing. And when you do graph, try to make sure that, if possible, you have concavity that shows up. Because at pi over 2, that just represents your point of inflection right here. This right here at 3 pi over 4 represents that it's going up, concave up. And this right here at pi over 4 is just concave down. Once you get those points and they are graphed and pretty, we're going to play a game of just copy and paste it. Lucky for me, I have Notability. Unfortunately for you guys, since this is on paper, you're going to need to sketch this out. Now, the test might ask you to graph the whole function from negative 2 pi to 2 pi. It might ask you to find 1 period. It might ask you to find 2 periods. So depending on what the test question asks you, that's how much you should graph. In this case, I graphed from negative 2 pi to 2 pi, but the test might ask something else. All right, number 9. I have a period of pi over b, or pi over 2, because of my b value being 2. I know that since I have pi over 4 right here, that I'm going to go left pi over 4 for my asymptote. And to find my asymptote, that's just going to be pi over 2b, pi over 2 times 2, or pi over 4. So this first pi over 4 represents my asymptote, and then this negative pi over 4 represents my phase shift, which means that once again, I have 0 as my asymptote. Once I have 0 as my asymptote, I'm just going to play a game of my period being pi over 2 and adding pi over 2 throughout. And in this case, I'm only going to work with 0 to 2 pi because I am feeling lazy right now. Your midline is at y is equal to negative 3, so we'll graph that. Then I'm going to find a midpoint. Your a value is 1, so I'm just going to go up 1, and then down 1, based off of my midpoints. And then try to use concavity and graph. Oops. And I'm going to cheat a little bit and copy and paste. It's also going to copy and paste that little dot, but it's whatever at this point. And there you go. All right, so number 10 features an a value, which is a really good problem. I have a period of pi over b, or pi over 1/2, which is the same thing as 2 pi. I have a phase shift of minus pi, and then my asymptote is pi over 2, and then times 1/2. Well, 2 times 1/2 is just 1, so I have pi, which means that once again, my asymptote will start at 0. Now, will this happen 99% of the time? No, but these problems were pretty nice, I would say. So we start at 0, and then we're going to go 2 pi. My midline's at 1, so I'm going to start there. Then I'm going to find my midpoint from 0 to 2 pi, which is at pi. Once I do that, I have a value of 2. And I want to find my midpoint between the midpoints right here and the asymptote, which gives me 3 pi over 2 and pi over 2. That said, I'm going to go up 2 and then down 2 to get those points. And then try to... Ooh, this is not pretty. That would do. Try to graph it as pretty as possible with the, let me try that again. As pretty as possible with concavity showing. As long as I have the 3 points, as long as you have the 3 points and that I can clearly see your concavity changing, I will be happy. All right, number 11 is a -1, but it's going to be the same process, so nothing to worry about. Pi over b, pi over 2 being your period. Your phase shift, well, I know that I'm going to go minus 3 pi over 2. And then I know that my asymptote is in the form of pi over 2b. So pi over 2. And then my b value being 2, which is pi over 4. All right, I have pi over 4, and then I'm going to subtract that by 3 pi over 2, which means that I have 6 pi over 4, which is -5 pi over 4. This one's completely different. I'm not starting at 0 now, I'm starting at -5 pi over 4. And then since I have a period of 2, I'm just going to go jump 2 each time. So you'll see how this one, my asymptote is not at 0. Which is A-okay. That's fine. I have a midline at -1. Then I'm just going to pick a point on a section. And my A value is 1. Now, because it is negative, we are going to go the other way around and reverse this. So I'm still going to go up 1, but I'm going to go up 1 to the left, and then down 1 to the right. That's actually a good concavity. Pretty. And for me, I'm just going to do maybe here. Alrighty, in the next video, I'm going to show you how to graph cotangent, which is very, very, very similar, except we just have different asymptotes.